Have you ever stood beneath a clear night sky and wondered what it would be like if the North Star simply disappeared? For centuries, sailors, explorers and dreamers have looked up and trusted that single, steady point of light, Polaris, to guide them home. But what if I told you that the North Star is not forever? Right now, Polaris faithfully marks the spot almost exactly above Earth's North Pole. It's so perfectly placed that as our planet spins through the darkness, Polaris barely moves, a shining anchor while all other stars appear to wheel around it. To ancient travelers, this star was more precious than gold. Vikings used it to cross stormy seas. Caravan traders traced desert paths by its glow. Even today, if you can find Polaris, you can find true north, a lifeline when compasses fail. But here's the secret. Polaris hasn't always been our North Star, and it won't always be. The sky we trust to be constant is, in reality, always shifting. Earth wobbles, the heavens drift, and over thousands of years, new stars rise to take Polaris's place as the cosmic compass point. So which star will be our next North Star? Why does the sky change at all? To find out, we have to understand the slow, graceful dance of our spinning Earth, and how it aims its axis like an invisible arrow through space. To understand why the North Star changes, you first have to picture Earth not as a static spinning top, but as a top that wobbles, slowly, gracefully, and constantly. This wobble is called axial precession, and it's the quiet reason the heavens drift over centuries. Earth spins on its axis, an imaginary line connecting the North and South poles. But this axis doesn't point in a fixed direction forever. Like a spinning toy top that starts to tilt and trace a slow circle as it spins, Earth's axis does the same. Only instead of seconds, Earth's wobble takes about 26,000 years to complete one full circle. Right now, Earth's axis points almost perfectly at Polaris, making it our trusted North Star. But thousands of years ago, Polaris wasn't in that spot. Ancient Egyptians looked up and found true north using Thuban, a star in the constellation Draco. Around 4,800 years ago, Thuban was closer to the North Pole than Polaris is now, guiding pyramid builders as they aligned stone with the heavens. As centuries pass, the axis shifts, sweeping out a slow circle in the sky. Polaris will drift away from the pole, losing its crown as the North Star. Another star will drift in to take its place, and future travelers will learn to find true north by a different point of light. But which star is next in line, and when will Polaris say farewell? To answer that, we have to follow the path of the wobble forward in time, and meet the bright star already inching its way toward the pole. If you could fast forward thousands of years, watching the stars shift in a time-lapse dance, you'd see Polaris slowly sliding away from the North Pole, while another star rises to take its place, a bright point called Vega. Vega is already one of the brightest stars in our night sky, easy to spot in the constellation Lyra. On clear summer nights in the northern hemisphere, you can see Vega high overhead, shining a brilliant bluish white. To ancient cultures, Vega was special, the harp star, a jewel in many myths. About 12,000 to 14,000 years from now, Vega will drift close enough to the North Celestial Pole to become our new North Star. Back around 14,000 years ago, Vega held that role once before, long before ancient humans even dreamed of mapping the sky with compasses or telescopes. Compared to Polaris, Vega won't sit quite as perfectly at the pole. It will hover a few degrees away, close enough to point the way north, but not as pinpoint accurate as Polaris is today. Future navigators will learn to make tiny corrections, just as ancient astronomers did when Thuban ruled the north. Vega's future reign reminds us that the stars are not fixed. They drift in slow, majestic patterns pulled by Earth's wobble and their own motion through the galaxy. What we think of as steady and eternal is really part of a cosmic clock, ticking off cycles that stretch far beyond a single human lifetime. So why does this slow wobble, this precession, happen at all? The answer lies not just in the stars, but deep inside Earth itself, in the silent tug of gravity and the bulge around our spinning equator. To see why Earth wobbles like a spinning top, we need to look at our planet's shape and the silent forces that pull on it every second of every day. Earth isn't a perfect sphere, it's slightly squashed at the poles and bulging at the equator. This bulge comes from the planet's rapid spin, about once every 24 hours. Like pizza dough spinning into a disc, Earth's rotation pushes out its middle, giving it an oblate shape. This equatorial bulge is the secret behind axial precession. The Sun and the Moon both tug on that bulge with their gravity. Instead of pulling Earth upright or tipping it over, they make its axis slowly trace out a circle, like a top whose handle gently sweeps around as it spins. This cycle, called precession, takes roughly 26,000 years to complete. During that time, Earth's axis points at different stars in turn, giving us a whole parade of north stars over thousands of generations. Precession affects more than just our guiding star. It also shifts the timing of the seasons over long ages, changing which stars are visible at night in each season. Ancient astronomers noticed that constellations seemed to drift over centuries, a clue that helped early scientists understand the deeper rhythms of our planet. So the next time you look up at Polaris, remember, it's locked in place only because of this slow gravitational tug-of-war. Without that bulge and those cosmic pulls, our North Star wouldn't exist, and future humans wouldn't have Vega waiting to guide them home. But Vega isn't the only star in this great cycle. Others have ruled the pole before, and more will follow long after Vega's reign fades. Long before Polaris, and long before Vega returns, other stars have taken their turn as the North Star in Earth's slow cosmic clockwork. Each one has its moment in the sky, a brief reign lasting centuries before the wobble of precession moves on. One of the most famous ancient North Stars was Thuban, a modest but historically important star in the constellation Draco the Dragon. Around 4,800 years ago, when the Great Pyramid of Giza was rising stone by stone, Thuban sat almost perfectly above the North Pole. Egyptian architects used it to align their massive monuments with astonishing precision. After Thuban drifted away, other faint stars marked the pole for ancient navigators. None were quite as bright or convenient as Polaris is for us today, which made navigation more challenging for sailors and explorers in certain eras. And Polaris itself won't be the North Star forever. While it's near perfect now, less than a degree away from true north, its closest alignment will happen around the year 2000 Re. After that, it will slowly drift away, just as Thuban did, surrendering the sky to the next star in line. As Earth's axis keeps tracing its circle, Vega will claim its crown in about 12,000 years, shining bright in the northern night. But even Vega's rule will be temporary. The precession cycle continues, and other stars, some not so well known today, will stand guard over the pole for future civilizations we can hardly imagine. This ever-changing cycle is a reminder that our night sky is not frozen in time. It shifts and flows with cosmic rhythms that span millennia, far beyond any single lifetime. So what does this mean for the explorers and dreamers who will look up to find their true north in the far future? And what does it mean for us now, living in this brief moment when Polaris reigns supreme? For us today, Polaris is more than just a star. It's a symbol of constancy in a changing world. Hikers, sailors, and stargazers all rely on its steady position to find true north when the compass needle falters or the sun is gone. To find Polaris, people look for the Big Dipper, one of the sky's most recognizable constellations. The pointer stars at the end of the Big Dipper's bowl draw a straight line that leads almost directly to Polaris, shining modestly at the end of the Little Dipper's handle. Its reliability has made Polaris part of countless legends and navigation stories across cultures. Escaping slaves on the Underground Railroad called it the drinking gourd, using its light as a guide to freedom. Seafarers once risked everything on stormy nights, trusting Polaris to show the hidden north when clouds parted. Yet this same fateful star is drifting, inch by inch, century by century, as Earth's axis swings slowly onward. Right now, Polaris is nearly as close to true north as any star can be. By about 2500, it will reach its tightest alignment, then begin its graceful exit from the pole. Future generations will watch Polaris slide away, just as Thuban did thousands of years ago. Perhaps someday historians will tell stories about us, the people who lived under Polaris's steady watch just before it began its long goodbye. But we won't be left starless. As the centuries pass, the sky will keep turning and a new guide. Bright Vega will claim the role once more. So, how will our descendants find north under Vega's watch? And what does Vega's return tell us about the grand cycles that bind Earth and sky together? When Vega takes its turn as the North Star again, it won't sit as perfectly above the pole as Polaris does now, but its brilliance will make it unmistakable in the night sky. Future navigators will look up and find true north not by pinpoint precision, but by making a small correction, because Vega will hover about 5 degrees away from the exact pole. For ancient people, that was more than enough. For future explorers, new technology will make tiny adjustments easy, blending ancient sky lore with modern tools. What's fascinating is that while Vega's reign is still far off, about 12,000 years from now, it's already drifting closer. Every year, our planet's slow precession nudges Earth's axis along its vast circle, aiming it ever closer to Vega's gleam. But even as Vega approaches its crown, the sky around it will change too. Over these thousands of years, constellations themselves subtly shift because the stars are not fixed. They move through the galaxy at different speeds and directions, reshaping familiar patterns over cosmic time. This means the Big Dipper, the Little Dipper, and the Harp of Lyra that holds Vega will look different for future stargazers. To them, the sky we think of as timeless will be a stranger, patterns warped by the invisible currents of deep time. And yet, despite these changes, people will still stand under the stars as we do now, searching for meaning, connection, and direction in the endless dark. A new North Star will rise, and generations yet unborn will place their trust in its steady light, just as we trust Polaris today. When Vega becomes the North Star once again, it will shine with a brilliance unmatched by Polaris. In fact, Vega is the 5th brightest star in the night sky, much brighter than the modest gleam of our current pole star. Its brightness made Vega a point of fascination for ancient skywatchers. To the ancient Chinese, Vega was the weaving girl, separated from her lover, the cowherd star, by the Milky Way's shimmering river. In ancient Mesopotamia, priests tracked Vega's movements as part of their early sky calendars. Its striking blue-white light has long been a cosmic magnet for myth, music, and poetry. In modern times, Vega continues to captivate us. It was one of the first stars to have its spectrum analyzed by scientists, revealing its secrets of heat and motion. It's only about 25 light-years away, close, as stars go, and so bright partly because it's so near. When Earth's axis tilts toward Vega in about 12,000 years, travelers of that distant age will have an easier time spotting it than Polaris today. Its brilliance will stand out, even in skies dimmed by future city lights. Assuming people still look up, but even as Vega rises to its future throne, Earth will keep wobbling along its cycle. Vega's rule, too, will be temporary. After several thousand years near the pole, Earth's axis will drift away once more, and Vega will begin its retreat, a bright king stepping back into the wider night. So, what happens then? who stands in line to be the North Star when Vega fades. The cycle never stops, and the dance of the heavens keeps writing new stories across the ages. After Vega's time at the pole, Earth's axis will continue its slow, steady wobble, bringing yet more stars into the role of North Star. Some bright, some faint, some nearly forgotten today. One such star is Deneb, part of the constellation Cygnus, the Swan. Deneb is much farther away and not as bright as Vega or Polaris, but it will approach the pole in about 18,000 years. Because Deneb is so distant, its apparent brightness will be much dimmer, making it a less reliable guide for navigation. Beyond Deneb, many other stars will take their turn over the course of Earth's 26,000-year precession cycle. This cosmic carousel will keep spinning long after humans are gone, or after new civilizations rise to watch the stars from other vantage points in the galaxy. In this way, the North Star is not a single eternal beacon, but a role played by many celestial actors across the ages. It reminds us that the sky, though vast and seemingly fixed, is a living, moving stage shaped by gravity, time, and motion. For us, in this brief chapter of cosmic time, Polaris remains a faithful guide. But knowing that change is inevitable connects us to the rhythms of the universe in a profound way. We are part of the story written across millennia, marked by shifting stars and evolving horizons. The story of the North Star, past, present, and future, reminds us how deeply connected we are to the cosmos. Polaris, Vega, Thuban, and all the stars that have held the pole have guided humanity's journeys, inspired myths, and anchored our sense of direction. Though the stars shift and Earth wobbles, the human desire to look up and find our place among the vastness remains constant. The North Star is more than a point of light. It's a symbol of guidance, hope, and the search for truth. As we stand beneath the night sky today, we hold a fleeting moment in this grand cosmic dance, a moment when Polaris leads the way. But far beyond our time, other stars will rise to take the mantle, their light traveling across centuries to meet new eyes. So next time you find Polaris shining steady in the north, remember, the sky is alive with change, and we are part of a universe that moves, shifts, and evolves, forever guided by the stars.